Hello everyone, this is Nidhal Shah from Computer Science and Department of Surat University of Science and Technology. Today I'm going to discuss about what generative AI is and how it has impacted specifically the computer vision domain. These are the table of contents where I will first introduce with generative AI, then how it works, then the various models of computer vision, how it is evaluated, its usages, challenges, followed by recent advances, then the live case study, as well as key takeaways. So, generative AI refers to the field of artificial intelligence that I'd say mainly focuses on creating models which are capable of producing original as well as realistic content, such as in the form of images, music, as well as text either. By leveraging deep learning techniques, it opens the doors to create multiple applications, but also we need to make ensure that it is ethical to use as well as it is potential without any misuses. So this is what basically a generative AI is, and in other terms, I would simply put it as a machine learning branch that uses neural networks to generate new data based on the training input. So it will give us a new as well as original content in the form of images, music, and that will be mostly indistinguishable from human created content. So this is what a general definition, a basic definition of generative AI. Now, how it works. So it is one of the breakthroughs that it has the ability to leverage different learning approaches, including supervised as well as semi-supervised learning, along with unsupervised training as well. So this has given organizations the ability to more easily and quickly leverage a large amount of unlabeled data set, to be specific, to create the basic model. So as the name itself indicates, that foundation models can be a base for particular AI system which have the task of performing into multiple ways. So examples of such base models include ChatGPT, which draws from GPT-3, and it allows users to generate a content based on a short text input. So on the other hand, it also allows users to generate photorealistic images with a given text input, which not ChatGPT is allowed to do so, but there are various other generative AI which helps us in producing such results as well. So this is how it basically works. And following that, the generative models for specifically computer vision, it includes GANs as well as autoregressive models. So it can be used to generate new images that are, as I said, indistinguishable from the real images, as well as the ability to generate new images is by the previous training input only. So in computer vision, to create new images as well as videos, it is useful. For an instance, I would say that it can generate a realistic 3D models of an object or a, let's say, building, which can be useful for the architecture to perform a particular layout based on the engineering practices. So this is how it is useful, and it also sometimes give us the realistic image of a people of an animal as well as people, as well as including the entire landscape. So this technology has been widely used in the cinema because to give the realistic effect as well as also in many such games either. So now coming to the evaluation of generative AI. So how it is evaluated, how these models are evaluated. So there are three key requirements. First of all, it is quality. So especially for applications that interact directly with users, which have high quality generation output is a crucial key for this. For an instance, in speech generation, poor speech quality is difficult to understand for mankind. But similarly, in image generation, the desired outputs should be visually different from the natural images. So this is what a quality factor is. Now the second factor will be diversity. A good generative model captures the, I would say, minority modes in its data distribution without sacrificing generation quality. So this helps to reduce undesired biases in the trained models. This is what diversity means. And about speed, then many interactive applications require faster generation, faster output generation, such as real-time image editing to allow use in content creating various workflows. So this is what the three key requirements for a generative AI model to be successful means. Now moving to the applications of generative AI, then first of all, synthetic, it is widely used for the purpose of synthetic photographs. So it includes testing algorithms as well as generating visual content. So some notable applications include data augmentation, where it can generate diverse and augmented training data by creating the varied real images. It helps to improve the robust structure as well and also to generalize the computer vision model. And moving further, it is also used for image in painting. So it is like if we want to fill the missing or damaged parts of an image with the realistic approach, then it is widely used for image restoration as well as to enhance that image. So this is what synthetic photographs means. Then the another application is medical imaging. So it has found extensive applications in this particular medical field, which helps in diagnosis as well as treating the patient based on the various research. So the one such usage is image enhancement. So it can improve the quality of medical images by reducing the biases as well as noises, which enhance the contrast and increase the image resolution, which leads to more accurate diagnosis. Then also it is used for cross-modality image translation, which means it converts the image from one modality to another. Let's say example is MRI to CT scan, and it can be helpful in combining this information from different imaging techniques for a more comprehensive diagnosis. So this is how it is used in medical imaging. Then followed by that, in the agricultural field, it is used for crop disease detection, which can be where the models are trained to generate images of healthy and diseased crops so that it helps in the development of disease detection algorithms. And also sometimes it is used for harvesting prediction, just like it generates images of crops at um, different stages of growth and thereby helping the farmers in predicting harvesting times as well as the um, amount of crop yield. Then another usage is super resolution. So what it means is it enhances the quality as well as resolution of images as well as videos in computer vision. So to cite an example with it is used for image upscaling, where it upscales the low resolution of the images to higher ones, so that by this, the quality of surveillance footage as well as satellite images and medical scans are improved. And also, it enhances the video quality for better video streaming as well as at a low bitrate. And another and the last one I would like to portray is about augmented reality and in virtual reality, AR, VR. So it helps in creating the realistic and customizable avatars for the VR environment by providing the immersive UI. And also the environment generation of the particular object in real time, it helps in creating such dynamic experiences as well. So these are some applications of generative AI in specific to the computer vision domain. Moving further, the challenges of generative AI includes unrealistic or distorted output. So it is like many generative models, such as GANs, can produce images that are mm, often remarkably realistic. However, they still have some artifacts, some distorted details, or to be precise, inaccurate textures. Because of that, the output is not always indistinguishable from real images. So this is how it affects the sometimes it affects the age, gender, or posture of a particular face while maintaining the realism. Following that, the bias and discrimination in image recognition. So I'm just discussing few challenges only due to time constraints. So yes, data set bias. So generative models often rely on large data sets for training, and if these data sets contain bias, then the generated images will inherit these biases. For example, if a data set is skewed towards a particular ethnicity, then the generated face will obviously have that bias in it as well. And about fairness and accountability, then if you want to ensure fairness as well as accountability with generative AI, then it is a bit challenging as it requires addressing bias and discrimination at both the data as well as algorithmic levels. And another challenge is ethical issues. So when during deepfake detection, generative AI used to create deepfake content where people's faces and voices are manipulated to produce convincing but fake videos or audio as well. This poses serious ethical concerns related to the privacy, misleading information, as well as potential harm as well. So it violates the privacy. In all, it violates the privacy as well. So this is what legal and regulatory challenges are for generative AI. And yeah, that's it. I say there are many more challenges like continual learning, deployment challenges, like it requires high processing computers as well. So the resources need to be managed accordingly. Now, recent advances in generative AI, where computer vision is the main point to be discussed about. So, style gain, that is generative adversarial networks for image synthesis. So, it is a class of generative models that excels the high quality image as well as resolution with a higher degree of controllability. These models are um, for their ability to control various aspects of generated images, such as the style as well as content and the specific an object attribute. So, fine-grained image synthesis is one such example for this, as well as to transfer the style as well as expression. Then style gain has been widely used nowadays. Then GANs for autonomous vehicles. So for simulated training environments, like uh, GAN are employed to generate realistic synthetic environments for training autonomous vehicle systems, where it helps in testing and training self-driving algorithms in a safe and controlled manner. So it is widely used in, I would say, object detection and segmentation as well, so that we can have a more reliable perception and ensuring safety as well. Then it is deepfake detection. Yes. So as deepfake technology has become more widespread, widely spread used technology, there has been a parallel effort to develop deepfake detection systems where generative adversarial networks, that is GANs, are used to create synthetic deepfake videos and images, which are then used to train detecting algorithms. But it has got efficient detection as well, where till date a work has been going on real-time and efficient defect detection models so that it can counter the rapid manipulation of the content on social media and other platforms. Last but not the least, AI enhanced photography. So super resolution is one such parameter in it where it is employed for to get the final resolution of an image so that the enhanced quality and resolution of photographs can be used in the area of architecture, medical, and likewise. So it includes the adjustment of brightness, contrast, color balance, and noise reduction as well. So all in all, these advancements make it easier for users to obtain high quality images with minimal effort. So this is what the recent advances in computer vision has been observed due to the involvement of generative AI. So there is one case study which is, I'd say, done by the OpenAI team, which they named it as DAL E1, which has two uh, crucial features. That is, it has a transformer based on their earlier popular model GPT-3, and it is learned from a huge data set of image description pairs, where most of them were scraped from the web. So, such models have many applications, both commercially as well as scientifically. And in the world of artificial intelligence, they can be helped in data augmentation, for example, generating larger training data sets of images in CV related problems. So the image on the right is the images on the right were given as an output when the text was like generate a generate images of a blonde girl with a smile. So this was the text, and the images which were produced were like this. So we can see that how it has made things easier for us with its advancement. So these evolutionary algorithms are mainly population based, and it can be used to replicate the way which we are entering it as a text. So likewise, it generates the variety of images for, let's say, even of an animal as well as cars or faces based on our input. More such information about this case study can be found on this link, which is just mentioned below the text. So moving further, here a clip is a part of DAL E model, which is made available by its authors, where it provides a link between image encodings and text encoding. So, all in all, to make it brief, it helps in evaluating the image quality in consecutive iteration, so that we can calculate the fitness function based on the image generated as well. So the most important element of the whole framework is the pre-trained GAN model, where it is also called generative network, which is introduced by ML world. So yes, it allows generating various images from a domain specified by the particular data set. It can be of cats, it can be of species, dogs, cars, and more such. So a basic summary. So with further research on and refinement of the technology, the future of computer vision will see it perform a broader range of functions. Not only computer vision technologies be easier to train, but also be able to recognize images, yes, much more accurate and efficiently than ever before. So it plays a vital role in the development of artificial general intelligence and super intelligence by giving them the ability to process information even better than the human visual system. So this is how generative AI has impacted the computer vision environment. And to be more precise, it will definitely going to be helpful to a larger extent for the mankind as well. Thank you.